We're continuing with the review for the Math 1111 final exam. We're on page 3 of the review sheet document under the heading Domain and Range of a Function. And let me remind you how to find the domain of a function. This first question does ask you just to find the domain. Remember that the domain corresponds to the usable x values for the function, and the range corresponds to the y values that you can use in a function. Typically with the domain, we basically can assume that the domain is all real numbers from negative infinity to positive infinity with two restrictions. And the two restrictions are that you cannot have 0 in the denominator of a fraction because you cannot divide by 0. And the second restriction, if you'll recall, is that you cannot have a negative under a radical. So pretty much we can assume that the domain for a function is all real numbers unless the function involves a fraction, which is a rational function, or has a radical in it, and then we have to be concerned about negatives. So when I look at this first question, it says determine the domain. So I'm looking for the x values, and I notice that the function is a rational function. It looks like a fraction. And so I know that the denominator cannot be 0. So we know that x squared minus 64 cannot be 0. And so then I need to solve that particular equation or inequality for x. Since it's a squared term, I can use a factoring or quadratic formula. I notice this is the difference of two squares, so I'm going to factor it. X plus 8, x minus 8, and neither of those pieces can be 0. So I'm going to say that x plus 8 cannot be 0, nor can x minus 8 be 0. Then I want to solve each one of those respectively for x. So first I'm going to subtract 8 from either side. So I have x equals negative 8, or does not equal negative 8. We can't use that value. Then we add 8 to either side as well. And so x cannot equal 8. So we think about that in terms of a number line. Basically what we're saying is that on our number line, we can use any number that we can think of on our number line with the exception of negative 8 and positive 8. So it's like there's a big old hole at negative 8 and a big hole at positive 8. But I can use anything on either side of those numbers or in between. So written in interval notation as requested, my domain is going to be from negative infinity to negative 8, not including it, so you use a parenthesis, from negative 8 to positive 8, not including it, use a parenthesis, or from positive 8 to positive infinity. And there's your answer. The next question says, determine the domain of the function f of x equals the square root of x squared minus 5x plus 6, and to write your answer in interval notation. Again, one of the first things I notice about this particular function is that it involves a radical, and I know when I have a radical that this expression underneath has to be positive, or it could be 0. So symbol-wise in mathematics, that means we're trying to say that it's greater than or equal to 0. So I take the inequality first off, and I want to solve. I want to fix it so that x squared minus 5x plus 6 will always be greater than or equal to 0. So I'm going to solve that quadratic. I'm not worrying about the greater than or equal sign at first. I'm just going to factor this and see what numbers I need to use. Let's see. So we have 3 and 2, and they're both subtraction. So then we know that either x minus 3 is equal to 0 or x minus 2 is equal to 0. And that gives us our critical values that we need to think about. Solving each of those respectively for x, we're going to add 3 to either side. So x equals 3. Then on the other one, we add 2 to either side. So x equals 2. Now, since this is an inequality and I'm trying to make sure that it's greater than or equal to 0, remember we take our number line and we divide it up based on those critical values. And then we have to do a test value in each region. So I'm going to start with a value that's over here less than 2. So let's say we do x equals, let's do -2. It doesn't matter what number we choose. We just need to choose one that's in that area. So if I plug -2 into the problem, I have -2 minus 3 times -2 minus 2, and that value needs to be greater than or equal to 0. So I would have -5 times -4, which ultimately is +20, which is greater than or equal to 0. So it works in that region. Then I need to try a value between 2 and 3. So probably the easiest one to do would be 2.5, 2.5. So I'm going to test that one. So I have 2.5 minus 3 times 2.5 minus 2, and we hope that's greater than or equal to 0. That gives me -0.5 times +0.5, and we hope that's greater than or equal to 0. That gives me -0.25, which is not greater than or equal to 0. So it doesn't work in this region. And then finally, I need to check it for a value bigger than 3. So let's maybe use the value of 5. So if I check 5, I have 5 minus 3 times 5 minus 2, and we want that to be greater than or equal to 0. So I have 2 times 3, which is 6, and 6 is greater than or equal to 0, so it works in that region. So we need the region to the left of 2 and to the right of 3. So written in interval notation, as requested, our domain would be from -infinity to -2, which can be used because it can be equal to 0, or from +3, not -2, excuse me, that should be +2, excuse me, and then 3 to +infinity. And again, the 3 and the 2 are included, so we indicate that with the brackets. The supplemental question under this topic says the domain of the function f of x equals 4, the square root of 4 minus 2x is, and it wants you to write your answer in interval notation. So here again, I notice that this particular function involves a radical, and so I know the expression underneath, 4 minus 2x, has to be greater than or equal to 0. This one's not quite as challenging as the quadratic one. So we're going to solve this for x. So I'm going to subtract 4 from either side. So we have -2x is greater than or equal to -4. Then I'm going to divide by -2 on either side. So x, -4 divided by -2 is 2. Now here's the trick. Remember, because you divided by the negative, you have to invert or flip the inequality symbol. So we get x is less than or equal to 2. So again, you can still think about the number line here, We only have that one critical value of 2, and it seems to indicate we should be less than. So you can kind of use a checkpoint just to kind of ensure that you get the right answer. Okay, so I'm going to maybe use x equals -2 and see what happens. So I have the square root of 4 minus 2 times -2. So I have the square root of 4 plus 4. Okay, 4 plus 4, which is 8, is greater than or equal to 0. It's a positive value, so I'm good. Now, if you want to counter that to guarantee yourself that you've kind of got it correct, if you want to try a value maybe like 5, then we would have the square root of 4 minus 2 times 5. So that's 4 minus 10, or the square root of -6. And we know you can't have a negative under the radical, so it doesn't work. So it is definitely, again, that's just a kind of a checkpoint for you to make sure that you got it right, especially with that sign inversion, flipping that inequality. So I can use 2. So we go from -infinity to +2. Visually, you would have the solid colored in dot at 2 and would choose anything to the left. Okay, one more. It says determine the domain and the range of the function f of x equals x squared plus 6x plus 8. Well, I notice in this particular problem, when I first look at it, it does not involve a rational function. It doesn't have a fraction, and it doesn't have a radical. So I know that the domain then is going to be -infinity to +infinity, which is the case for any quadratic function. I also know I haven't actually graphed it. I could use my graphing calculator and create the graph so that I could see it. I would have, oops, excuse me. I can type in x squared plus 6x plus 8, and I can create the graph. If I don't remember or realize that this function is going to be a parabola. And in terms of a parabola turned upward, as we saw on the graph, the low point occurs at the vertex. So I need to determine the vertex of this particular function. You have the vertex formula on the formulas that are listed at the beginning of the exam or for the formula sheet. But remember, the h coordinate is the opposite of b over 2a, and you find k by substituting h back into the problem. Now, a, b, and c here, remember, a is the number in front of the squared term, which is an understood 1. B is in front of the linear term, and c is the constant. So I have -6 over 2 times 1. So -6 over 2, or -3. That's your x coordinate of your vertex. To find the k, we're going to substitute -3 back in. So we have -3 squared plus 6 times -3 plus 8. So I would have 9 minus 18 plus 8. 9, -9 plus 8 gives me -1. So my vertex in ordered pair form is -3, -1. The y value there is the -1. So visually, my range, where I would start seeing it on the y-axis, would begin at -1, and it opens upward. So we go to +infinity. Again, you may be able to see that better if you look at your graph and realize, oh, you're going to start at what appears to be -1 and keep going upward.